All right, hey, what's going on, everybody? So just gonna go ahead and get started here. We got the Chapter 8 assignment, and let me grab my pen and everything. So for Chapter 8, again, our 10 problems: 1, 8, 3, 9, D, 11, 14, 19, 23, 31, 36, and 40. So for the first one, 1A, looks to be, and for this problem here, it's just calculate the moment of inertia with respect to the x centroidal axis for the area shown. For A, we've got a rectangle with a 8-inch diameter hole in it. So let me just draw that here real quick. We've got 24 inches on this side. And we've got 12 inches on the top there. And looks like we've got our x axis, which I'm gonna actually draw this in green. Got our x axis here. And it looks to be symmetrical also, straight down. And as I mentioned, this is 8 inches in diameter. All right, so for this problem here, first thing that we got to do is just grab our calculations here for our first object, which we're calling the actual square or rectangle itself, the first one, and we're just calling this inside circle, we're calling that the second one. So IX1, and these are going to be coming from, I believe, in the back of the book here. Table number 3. And as it says, for the moment of inertia of a rectangle is BH cubed divided by 12. So we'll just write that. BH to the third power, divide that by 12. Which is going to be equal to our base, which we know our base is 12 inches, and then our height, which we know our height is 24 inches. Don't really need the inches symbol there. And then we want to make sure we raise that to the third power, divide everything by 12, and we get a total value of 13,824 inches to the fourth power. And for IX2, moment of inertia about the x-axis for the second object, which is a circle. And that one, again, from the back of the chapter or back of the book, table number 3, we have our equation being pi d4 divided by 64. And that equals to pi times the diameter. Diameter is what? 8. And that's to the fourth power, divide everything by 64 again. And so therefore we have a total value of 201 inches to the fourth power. So then our total Ix, moment of inertia for this entire object, is going to be basically Ix1 plus Ix2, which we get Ix1 being 13,824. And for Ix2, you guys have to remember that this is a hole, and holes are being cut out. So therefore, we have to subtract the area. Basically, we're just subtracting material from that block, and that changes the moment of inertia of it. So we're actually subtracting 201 for a total value of 13,623 inches to the fourth power. All right, next one is number 3. And 3 says a structural steel wide flange section is reinforced with 2 steel plates attached to the web of the member as shown, which I'll draw here shortly. Calculate the moment of inertia of the built up member with respect to the XX centroidal axis. So let me just draw this here real quick for you guys. We've got a top got a top, we've got a bottom, and this is kind of like an I-beam, right? Boom, boom. Sorry for my horrible drawing. And then of course we got, this is kind of like a composite. So we got some plates over here on the side. Like that. Up here is a W18 by 71. So we can automatically know that that information there is going to be found in the back of the chapter or back of the book again. I believe this comes from Appendix A. This comes from Appendix A. All the information, moment of inertia, area, all that good stuff there. What else information do we have? We say this plate, these plates are 15 by 1. So that'll take into account as well. And then we know that our axis here, I'll draw this in green. This is our XX centroidal axis. All right, so first thing that we will want to do for this problem here is calculate the IX. And again, we're just calling this 1. We're calling this 2. And of course, we got two number 2s because there's 2 plates on there. So we have to make sure that we take that into account as well. IX for 1 is this equal to 1170. Again, this comes straight from the back of the book, from the appendix. And then IX2 is going to be the moment of inertia for a rectangle, because you can see this is just a simple rectangle, which again is going to be BH cubed divided by 12. So that's going to be base, which is 1, height, which is at 15, cubed, divide that by 12. And then don't forget, this is also going to be multiplied by 2. So actually, I'm just going to go ahead and factor this into the equation, multiply by 2. And the reason being is because we have 2 of those rectangle plates on the side. So therefore, IX2 is just going to be equal to 563 inches to the 4th. And then lastly, we have our total moment of inertia here, which is IX1 plus our IX2. In this case, we're not subtracting anything. So therefore, we just know that 1170 plus 563 is going to be equal to 1733 inches to the 4th power. All right, so next problem here is going to be number 9, and this is going to be letter D, so just 9D. And for 9D, it says, calculate the moments of inertia with respect to both centroidal axes for the area shown. And D looks like this. We've got our Y, our YY here. Our X is at some point off the base here. This is going to be 5. This is going to be 5. And this is going to be 15. With the total height 10. And all these are in inches, by the way. Don't forget your units, please. All right, so number 9. Where's this at? So for this problem, easiest thing to do, again, with these problems, you just want to break them up into information that you already have access to. So since we have access to basically since we have access to basically all of the standard geometric shapes, circles, squares, rectangles, semicircles, and stuff like that, we want to try and break this up into, you know, some shape that we're used to. In this case, what I see here automatically right off the bat is I see triangles and squares, or rectangles, whatever you want to call them. So I know that information there. So that means the top here is 10, and that's 10 for the top for the rectangle is 10, 10 for the height of the rectangle, 10 also for the height of the triangle, and then for the base of the triangle, I would say it's 15 minus 5 to get this area here. So 15 minus 5 is just 10. So this base here would be 10. If I'm looking at that right? I think I have it drawn super wrong, but yeah, this will be 10. This over here will be 10 also. So the base is 10, height is 10, and heck, same for our rectangle, looks like. All right. And let's see. So I'm going to consider this being my 1. I'm going to be considering this being my 2. Of course, there's 2 of those. And let's see. So in this case, also it's it's symmetrical. So I really only have to deal with half of it, and then, you know, factor in the other half kind of separately in this case. So let's see. So we got our area of our first one. No, I don't think I want to do it that way. I mean, I'll just be multiplying everything by 2, right? Yeah, that's cool. Area for the first one, area of a rectangle is just length times width. So length times width, and the length of it is going to be 10. The width of it is going to be 10. So we got 100 inches squared. The second one is what 1/2 base times height, if I'm not mistaken. The base of the triangle is 10. Oops, 10. The height of the triangle is 10. You got to divide everything by 2. So 10 times 10 is 100 divided by 2 gives us 50 inches squared. So therefore, our y bar in this case is going to be our sum of our areas times y divided by the total area. So for and I probably can actually just do this. A1 y1 is going to be the area, which is at 100, times y. And remember, y is just the centroid of that shape. So the centroid of a square is essentially right in the center of it. So that's just going to be not 10. It's going to be 5. So half of 10 is 5, and therefore we get what, 500. And then A2 Y2, that's going to be the centroid of that is I think h divided by 3, if I'm not mistaken. Let me see. Yeah, h divided by 3. So the area we know is 50. Y we know is going to be h divided by 3, which h is 10. And so therefore this is going to be, if I run out of space here, let me grab my calculator also. 10 divided by 3 is what, just 3.3, right? 10 divided by 3 gives us 3.3 repeated times 50. That's what I really need, is 166.67. So therefore, our sum up here, A1 y1 plus A2 y2 divided by A, is going to be equal to, at 500 plus 166 point, I'll just say 0.7. And remember, there's two of them. So when we do this part of the problem, remember there's two triangles that we have to deal with. So we just got to either multiply everything by, or multiply this by 2, or we can just add in the second one, 166.7. I'm just writing it that way just because. Now I just want to make sure you remember there's 2x, there's 2 of all of these. And then divided by the total area. Total area that we have is going to be 100. So that's A1 plus A2, which actually, let me write it down here. So we just got A1 plus 2 times A2. So 2 times A2. And this total value here is going to be now I'll just put this as 50. So the total value here is going to be 4.17. All right. So then from there, now that we grabbed our areas, now we can grab our actual I values for them. So Ix to the first, or Ix1 is base times height, base height cubed. Divide that by 12. Not equals plus 8, was it AD squared, right? Boom. Plus AD squared, which is 100 times D, which I got 0.83, and that's squared. And remember, D value is just equal to y, was it y bar minus y? I guess D1 is equal to y bar minus y1. So in this case, we would get 902. Yeah, 902 inches to the 4th power. Ix2 is equal to 10 times 10 again to the 3rd power divided by 36, plus again AD squared, which our A was 50. The D in this case, again from the Y 0.83 squared, and we get 313 inches to the 4th, for a total Ix of 902 plus 313. And again, there's 2 of these, so we do plus 313 again since there's 2 of them, or you can just multiply it by 2, and we get 1528 inches to the 4th. Then we can come over here and do y1, or Iy1, as well as Iy2. It's going to be essentially the same thing, just coming from the y-axis though. So 10 to the 3rd, divide that by 12, and we get 833 inches to the 4th. For number 2, 10 to the 3rd, divide that by 36. This one actually does have a AD squared because it has a distance away from the Y. So A is 50, D is going to be 8.33 squared. 3747 inches to the fourth would be the answer. And so therefore our total IY is going to be equal to 833 plus 3747 plus 3747 equals 8,327 inches to the fourth power. Alrighty, that was what, 9D? So then we could jump over here to number 11.
Destroy it, honey.
And for number 11, we say, or we have a problem that says the rectangular area shown has a square hole cut from it. Calculate the moments of inertia of the area with respect to the x-axis and total axis and its base. So you got to calculate it twice, essentially. Bless you. So we got to calculate this twice, essentially. We got that. We've got that. I'll go ahead and throw in here my XX. And then I'll also throw in here my X prime, along with my YY.
Destroy it now. You better destroy it, because when those hatch, they're annoying.
And these is going to be
Oh my god.
2 inches there, 2 inches here. So this is a 4x4 square hole.
What the frick? What the frick are those things? Bro, what the frick are you?
Up here is going to be 24. So yeah, so on this problem, again, we have to start with our general stuff. Find the areas, find the y, then find the moments of inertia. I'm calling this big old rectangle 1, and I'll call this small cutout square 2. So the area for the first one is going to be length times width, which is 12 times 24. Give us 288. And the y in this case is going to be fairly easy to solve. It's just half of the height, so that's 6 inches. A2 is going to be length times width again, which is 16. Don't forget your units, by the way. Area, get units squared. And then the y value is going to be that center location. So this is going to be 4.
I'm helping you. I'll help you. Get him.
And so therefore y bar is equal to the 288 times 6 minus the 16 times 4. Again, we're doing minus because it's a square cutout. And then we got 288 minus 16 for the total area, and we get 6.12 inches. And then for IX1 is going to be equal to 24 times 12 to the cube. So, you know, just BH cubed divided by 12. Plus our AD squared. A was 288. D was 0.12 squared. And we got 3460. IX2 is going to be equal to 4 times 4 cubed. Divide that by 12. plus our AD squared. So A is 16, D was 2.12 squared, not plus, sorry, equals 93 inches to the fourth. Remember, this is going to be, I'm going to just go ahead and write it here. This is going to be a negative value. That's going to be a negative value because that's a cutout. So therefore, our IX total is going to be 3460 minus 93, which gives us 3370 inches to the fourth. And then for IY, well, not Y, sorry. So we did IX, now we got to do IX prime. Sorry about that. Just coming from a different location, IX prime. And that's going to be 24 times 12 to the cubed power, third power, whatever. Divide that by 3, which gives us 13,820 inches to the fourth. So you see we use a different equation here, just depend on where we are coming from and stuff like that. And that's again, just depend on how you're doing the actual problem. Again, that comes straight from the back of the book, table number 3, the back cover of the book. So IX prime for number 2 is going to be 4 cubed, divide that by 12, plus our AD squared, which is 16 to the fourth, or 16 times 4 to the second power, which give us negative, don't forget your negative 277 inches to the fourth. So therefore IX prime is equal to 13,820 minus 277 gives us 13,540. All right, so moving right along, number 14 here. Number 14 says, calculate the moment of inertia with respect to the XX and total axis of the built-up timber member shown. Use the rough dimensions given. So please note these are rough dimensions, and it looks something like this. Alrighty, so it looks like this is all the information that we have here. Yeah, I think that's all the information that we have here. And we do know this is made out of timber, so definitely please make note of that. And yeah, so I guess we can just call this being number 1. It's on the top. We can just say these 2 side pieces are number 2. There's 2 of them, so we just got to multiply those by 2 once we get done. So area, that's just gonna be 24, and we get that because what's this? They didn't really sell us, but 2, 4, 8, and 4 times 4 was what, 16. A2 I'm sorry. Wait. So this is not 4 times 4. Sorry. I put wrong one. Let me erase that real quick. So 4 and 4 makes 8. Plus 2 makes 10. Plus 2 makes 12. This is 12. So now 12 times 2 gives us 24. There we go. I was confused for a second. So again, this number 2 is 12 again times 2. So therefore we got 24 for our area for that one. The y, this one's real easy. It's just 6. And then this one would be the 12, the total 12 plus half of the top. So the y for this one is equal to 13. And therefore y bar is 24 times 13 plus 24 times 6, and then we want to make sure we multiply all of this by 2. Divide that by 24 plus 2 times 24 to get a value of 8.33 inches. All right, Ix1 is going to be equal to 12 times 2 to the third power. Divide that by 12 plus 24, which is our area, times d, which is 4.76 in this case, squared. And if you guys have any troubles locating or solving for d, it's not too crazy hard. But once you have the y distances, you just basically subtract them to find how far away from each other are for the xx, for the xx axis, and for the y y1 and y2. That's how you get d. And this is 531 inches to the fourth. And x2 is 2 times 12 to the third divided by 12 plus 24. The d for this one is 2.33 equals 418. And so therefore Ix total is just 531 plus 418. And again, we can just multiply those by 2 because there's 2 of them, and the total value is 1,367. Number 19 is compute the radii of gyration with respect to the x-axis and y centroidal axis for the aluminum extruded shape shown. I'll just go ahead and draw this shape here.
I don't know. It seems to... Why are you screaming? I'm not. Yes,
Look.
you are. Oh, you died.
When did it die?
That was your turn.
No, it wasn't. Cause I'm not on ammo.
That you?
Yes, it's me.
Okay, then why did you bring this to me?
My gun.
What?
So the thickness of this part here is a 1/4 inch. So I'm just gonna write
That was you? Bro, he's right there.
104 inches here. We got the Y. We've got the X.
These guys are pros.
These two sides are 3/4. The center is 1 inch.
Wait, you can get your own team.
And then total height is 2.
Starting to attack. But, so you were about to do that?
Alright, so for number 19, we've got a couple of things going on here. In a way that I kind of broke it up is like this. So I'm just going to draw pink lines to where I broke it up at. And I'll just say, and I'll just draw this in pink also. I'll say this was number 1, number 2, and number 3. So therefore this is 3 also, and this is number 2. And that was essentially the easiest thing to do here in this case.
Right inside there for me to get sent home. See? Person.
And so this is, we already know that the thickness of the part is 1/4, so 1/4. So that's why this one here would be, we'll say this from there to there is 1/4. Same with this side here is 1/4. So what's 1 inch? Oh no, this is, yeah, this is already 1 inch. Yeah, that's cool. So we got 3/4 here at the bottom minus that 1/4. So we'll say that this here is just 1/2. Same with over here. Then we can also say that, you know, all of this from here to here, this is 1/4. Everything is pretty much 1/4. Alright, so just laying out some ground stuff first before we kind of dive right into it. And so for this problem, I have a table already set up in place with everything in it. So the area of the first section is just going to be 1 times 1/4, so 0.25. The area of the second section is just going to be, what's that, 2 times 1/4, so 0.5. Area of the third one is going to be 1/4 times 1/2, which gives us 0.125. The wide distances, 0.125 for this third one, because basically it's just half of that. Wide distance for the other one should be 1, because it's half of 2. And the wide distance for the top one there is just going to be that full height 1 minus, what's that, half of 1/4, so 0.125. So it should be not the full height is 2. Sorry, full height 2 minus 1/4, or half of 1/4. So that's going to be 1.875. And then for AY, it's just both of these two numbers multiplied together. So we get 0.469, 0.5, and then 0.0156. When we sum all of our areas up, we end up getting 1.5, and we sum all of our AYs up, we get 1.5 again. This is to the third, this is squared. So therefore our Y bar is just 1.5 divided by 1.5, which gives us a total value of 1 inch. From there, set up the next ones, which I would say we had D in the X direction, D in the Y direction, I in the X direction, and I in the Y direction. All right, so our D value for the X direction for the 1, 0.875. This is 0. This is another 0.875. Again, these are in inches. D value in the Y direction, though, is 0, 0.625, and 1. So therefore, our IX value is just going to be 0.0013, 0.1667, 0007, and the Y value 0026, 0026, 0208. So for our total IX, we get the 0.0013 plus 0.25 times 0.875 squared. So I'm just doing all the sums of our IX's here. So the IX plus AD squared, got to sum all those up. So that's the first one, plus the second one, which is 2 times 0.1667 plus 0. Plus, hopefully I got enough room, 2 0.0007 plus 0.125 0.875 squared. And this gives us a total value of 0.719. IY is going to be similar, 0.0208 plus 0 plus 2.0026 plus 0.5, whoops, times 0.625 squared plus 2.0026 plus 0.125 times 1 squared. And we solve that to be 0.672 inches to the fourth. So therefore our radii of gyration, Rx, is just going to be equal to the square root of 0.719, divide that by 1.5. And for Ry is equal to 0.672 divided by 1.5, and that equals 0.669, while this equals 0.692. These are both in inches. All right. So we got four more. Number 23 Where's my number 23 at? Calculate the polar moment of inertia for a circular hollow steel shaft with an outside diameter of 3 inches and inside diameter of 2.5 inches. And this one's actually fairly easy. Honestly, really only have one thing to do, which is calculate that polar moment of inertia. Don't even really need to draw much on it, but I'll just go ahead and draw just so you guys can kind of see it. It said I had a outside diameter of 3 inches. Inside diameter of 2.5 inches. And polar moment of inertia, as we know, the equation for that, for a hollow circular shaft that we just get from the table, hollow circular shaft is pi over 32. And since it's hollow, we got to do d to the 4th power minus d. I'll just call this do minus di to the 4th power. So that equals pi over 32 times 3 to the 4th minus 2.5 to the 4th equals 4.12 inches to the 4th power. And that's it. Really quick problem there. 31. Oh, there it is. For the cross-sectional area shown, calculate the moment of inertia with respect to the horizontal x and total axis. So 31 looks like this. Hopefully I can draw it right. We got this, that, and we got boom, boom, boom. Actually, no, I did this top one wrong. There we go. And then we have our XX here. Our values. All right, so I'm gonna just scroll this down here. All right, so for 31, first thing that we want to do is kind of start off with, as we know, our areas. We've been pretty much doing this the whole time. I'm gonna say this is gonna be 1. This is gonna be 2. So for area, for the first one, it's just gonna be 24.375, which gives us a total of 9 inches squared. And A2 is just 3.61 inches squared. So therefore our IX for 1, base times height cubed, right? And that gives us 432. So therefore IX2 is It's going to be 4.86 plus 3.61. Multiply that by our 11.067 squared. And we have technically 4 of these. What's it called? We have technically 4 of these on the 2 on the top, 2 on the bottom kind of situation there, right? So we got to multiply that by 4. So therefore we get 1788 inches to the 4th power. And so lastly we have our total Ix is just 432 plus 700 or 1788. And this gives us 220 inches to the 4th. 2,220, sorry. 2,220 inches to the 4th. Number 36. Number 36 says, a structural steel build-up section is fabricated as shown. Calculate for 1 the moments of inertia and for 2 the radii of gyration with respect to the x-axis and the y-y centroidal axis. So essentially it looks like this, and this is a, what is it, a W 8 by 40. Got a XX, got a YY. Since it's a W8 by 40, we know that we can go to one of the appendixes, grab some information from it that we already know that we need. This is 11.7 inches squared, 146 inches to the 4th, 49.1 inches to the 4th. And so therefore, we know we need our moments of inertia here. Ix is going to be equal to, and there's 2 of them. So since we know there's 2 of them, we want to make sure we multiply this by 2. Plus AD squared. Multiply by 2. Gives us 690.2. Iy is just going to be equal to 2. It's a little bit more simpler. 2 times 4, d9.1. And that equals to 98.2 inches to the 4th. So for B, our radii of gyration, we get Rx and Ry. And it's going to be 690.2. Divide that by 2 times the area, as well as 98.2 divided by 2 times the area for this one. And again, this is square rooted. Just kind of run out of space there, sorry. 5.43 inches and 2.05 inches. And what is this, the last one? Yep, number 40. 40 being the last one here. Calculate the polar moment of inertia with the centroid. Calculate the polar moment of inertia about the centroid of an area that is hexagonal in shape and 6 inches on each side. So number 40, it's hexagonal, so we automatically know that we have something that looks like this, that, and then on the same side, probably a little bit more square than what I drew it, but we automatically know we've got our XX there. Well, actually, let me kind of switch this up a little bit here. The way I did it at first was actually the other way around. So if I do it that way, it'll be kind of a little bit different. So let me put the flat on the top, because that'll kind of matter there. So this becomes our YY, and this becomes our X. And again, as I mentioned, for these problems, when you're dealing with like the areas and stuff like that, put them in stuff that you recognize already, that you know you can grab. This one here, kind of see, if I do that, now I have a triangle on the left. I do it on this side, I have a triangle on the right, and in the center I've got a rectangle. So therefore, and I think they said, what was it, 6 inches, right? All the flats were 6 inches. So therefore, this here from there is 3 inches, right? So that'll be kind of like the height of the triangle, and then the base of the triangle here the base of the triangle here, just make sure I want to do that right, we get 5.196 inches. So that's just doing a little bit of geometry or whatever to find that information there. And so therefore we have the area of the first one being this. We're considering these being the second. Area of the first one is going to be, what's that, 6, right? 6, because this right here is 6 inches from there to there. All the flats are 6. Then we're going to multiply that by the height. The height is going to be that 5.196 times 2, because the 5.196 is only half of the height, so we got to multiply by 2 to get the other half there, and that's 62.35. Area 2 is going to be 1/2 base times height, right? And of course there's 2 of those, so we got 1/2. The base is 5.196 times 2. So again, this is 5.196 times 2. The height being at 3. So we get a total of 15.59. And so therefore, the sum, and again, like I said, there's 2 of these, 2x. So the sum of our areas is just going to equal to the 62.35 times 2 times 15.59. which gives us 93.53. Just going to move this down slightly here. So yeah, so where do I want to write this? IX 6 times 5.196 times 2. Again, times 2 just because the 5.196 is only half of that value. And then we got to cube that, right? Divide that by 12. And we get 561.1 inches to the fourth. IX2, this was 1. It's going to be 3 times 5.196 times 2 cubed. And we're going to divide that by 12. And technically there's 4 of these little right angle triangles. It's 4 right angle triangles, so multiply that by 4 and we get 140.3 inches to the fourth. So therefore our total IX is just going to be equal to 561.1 plus 140.3 equals 701 inches to the fourth. And then for our IY in this case is going to be equal to that 5.196 again, times 2 of course, times 6 in this case, cubed. And we're going to divide all that by 12, which gives us 187.1 inches to the fourth. IY to the 2 is going to be equal to 5.196 times 3 cubed divided by 36. And then we're going to add in, factor in our 15.59, divide that by 2. Was it area? So 15.59 times D, 4 squared. And of course, we also got to factor in that there's 4 of them. So we get 514.5 inches to the fourth. So therefore our IY value is 187.1 plus 514.5, and that gives us 702, which is really close to our IX inches to the fourth. And then the last thing that we have to do is they asked us to do the polar moment of inertia, which is just our IX plus our IY. I'm going to throw this up here just so I don't have to make room down below. IX plus IY, so that's 701 plus 702 should be 14 something, 1403 inches to the fourth. Alright, so as always, hope you guys found some value in this. I'll be go ahead and posting this shortly, and then I'll make sure that you guys have the transcript and everything for it as well. Let me know if you have any questions, and you guys have a great rest of your day.